Welcome to the lecture series on big data with Hadoop. As part of this lecture series, today we will be focusing on filtering patterns. So, first of all we will see what is filtering pattern, then we are going to see different types of filtering pattern. So, as per the name indicates that filtering, it does not change any of the records, it will not change any of the records, it just takes the subset of the data, or else it extracts or retrieves the subset of data from the whole data set. The data which is extracted, it might be smaller, just like extracting only 10 records from the entire data set, top 10 we can say, or else retrieving the results by removing the duplicate, or else you can say distinct or unique from the entire data set. It might be large as like unique data set. Basically this filtering we are going to apply to get an understanding. Yeah. So why we are going to apply filtering is to get an understanding on the entire data set by focusing only on the smaller piece of the data. That is a major requirement why we are going with filtering. Coming to filtering, we will have 4 different types of filtering when it comes to design patterns using MapReduce. Firstly, a generic filtering. This is also said to be a generic filtering. We do have blue filtering, top 10 filter and distinct. So, these are the 4 filtering patterns which we are going to focus under filtering topic. So, the first one is filtering pattern using normal generic filter. In the generic filter, what it does is it evaluates each of the record in a data set. It evaluates each of the record in the data set based on certain condition, and if that condition matches, then it decides whether that record has to be retained or that record has to be rejected. And coming to this evolution pattern, if you treat evolution function as f, and this evolution function will return a Boolean variable, it will return a Boolean variable which might be a true or false. If the Boolean is true, then it has to retain the record, otherwise if it is false, then it has to let it go, that record. This is a simple thing which generic filtering will apply. Coming to the motivation of this, basically when we get into any of the big organizations where they are using Hadoop as their big data processing framework, they will collect the entire data set at one particular location. Processing on that huge amount of data is a bulky, not a good idea with which we can go. So, we have to retrieve certain smaller pieces of code which we will say as subset of data. If you are performing on the subset of data, then it will give a more elegant, efficient results when we are working with the whole data set. And not only to retrieve the subset of data, even we can use this filtering to zoom in to a data set of our interest. So, these are the 2 things which we can do with filtering. And the applicability area, as it is said that we can the only requirement of data set is that you have to parse the records. If you can parse the records of a particular data set, then you can apply this filtering, and the applicability area is widely useful. This filtering is widely acceptable and applicable in various fields and sectors. Coming to the structure of the filtering pattern, here we do have only mapper class for filtering. We do not have any reducer if you are going with generic filtering. What happens here is on the input plate, you are going to apply the mapper where it has a condition to filter out the records, and after filtering out, it provides the output. Here no aggregation function is going to be applied, only it has to match the things and it has to retrieve the data and it has to be returned to the output file. Coming to the known use cases, to have a closer view on the data, where you can have a focused subset, where you can explore that particular subset. And a distributed grep, this is a grep is a tool of Linux, where you are going to grep by matching certain line by line code or line by line in a particular file, and you can extract the output. Grep is a inbuilt tool in Linux, where it performs on regular expression. And the third thing is simple random sampling. If you are getting into machine learning, then if you are performing any sampling technique, if you want to extract the sample, then you can use filtering mechanism over there. And to get on with the filtering example, we will be considering distributed grep, where this particular grep is way dated back as a tool in Unix to retrieve the output which matches it, which performs on a regular expression. So as I said you, we do have only mapper class in generic filtering. So the logic over here is you are going to get the regression, or else whatever the area of interest or to which you want to map, and that is going to be mapped with the each and every line of a particular file. If it matches, it will be, the value will be returned to the thing. Whereas key, we are going to write a null writable. Null writable is an interface class in writable, which returns null value. Moving further, what is a Bloom filtering? Coming to Bloom filtering, it is as similar as to your generic filtering. The only difference over here is whatever records which you are going to match, that will be matched with a predefined unique evolution function. What is this unique evolution function that we are going to get to know? This unique evolution function is nothing but you are going to predefine a set of values. If you do have a data set, you are going to retrieve the records, and from that records you are going to retrieve the features. What I am saying over here, if you do have a data set, from this data set you are going to segregate the or separate the records, and on these records what you are going to extract? You are going to extract the features, and these features are said as predefined set of values, features of a particular record, and that predefined set of values are all said as a hot values. That predefined set of values are stored onto your HDFS, and those values are said to be hot values. And whenever you want to extract for each record, you are going to extract the features, as well as when you want to compare, you are going to compare the records with these hot values. If it matches with these hot values, then it is going to be retained. If it is not matching with the hot values, then it is going to be let to go. You are going to reject that. So the only difference between normal generic and Bloom is that you had a predefined set of values in Bloom filtering. The same thing has been explained over here. The motivation behind that is Bloom filtering is similar to the generic filtering. The two major differences: one, you are going to extract the, you are going to create a set of membership of operations which are set as hot values, and second, this set membership is being evaluated with a Bloom filter. These are the two major things which falls under your Bloom filtering. Coming to the applicability area, data needs to be separated into records. That is the first criteria which it has to meet, and second criteria which it has to meet is the extracted record needs to be sent into hot values, and the third one is it has to check the values of the records with the predetermined values which are said to be the hot values. And lastly, if the result is false, certain false positives are going to be acceptable. Every time we are not going to get true positives. Sometimes false positives needs to be acceptable. And coming to the structure of this Bloom filtering, you do have two stages or two phases, where in step 1 you are going to create a predefined hot values, and it will be stored onto some storage mechanism or certain disk. We are treating over here it as HDFS. And coming to step 2, the each input split you are going to apply mapper, and you are going to extract the features, and these features are going to be compared with the hot values which you had saved. It is being retrieved from a distributed cache, and these features are going to be tested with each other. If both are mapped, then it is being written to the output file. If there is no match, then it will be discarded. So, the Bloom filters which are stored, those are mapped with the records, and if it is matching, then it is written. If it is not matching, it is getting discarded. The next filtering technique is top 10. As the name itself indicates that it is going to retrieve k number of records, as we are tending it as top 10, then 10 number of records are going to be retrieved from a particular data set, and this is mostly used to find the outliers in a particular data set, as outliers are the most interesting part in any machine learning task. So, to find out the outliers, we use filtering mechanisms, especially it is top 10, as it hampers the entire result, outliers. And coming to the applicability area, this pattern is applicable wherever you require to retrieve any top 10 or least 10 or something, where you require a specific number of records from a particular data set. Such as if I want to know what are the top 10 movies list in a IMDb, there you can apply this type of filtering mechanism. And coming to the structure of top 10, from each and every input, it retrieves top 10 mappers or top 10 records by applying the mapper logic from each and every input split. Once mapper has retrieved the top 10 from the local input split, it will be, all these top 10 will be sent to the reducer phase. In the reducer phase, what we are going to do? We are going to list out the top 10 from all the top 10, which are the output of mapper, and the final result will be top 10 of all the reducers, and it will be returned to the output file. This is a flow how it gets evaluated. The last and final filtering mechanism, which is distinct filtering. As the name itself indicates, it will be retrieving the unique set of records from a particular data set, just like unique set of values from a particular data set. Coming to the motivation, here we are going to reduce the data from the actual data. That is one point which is being used. The other thing is, one such use case is you can just remove the deduplicacy of records. The duplicate records you can just remove from a particular data set, so that you can come over with certain storage space complexities also, as these duplicate values occupy certain space on the disk. You can reduce the space consumption also by using distinct filtering mechanisms. Coming to the applicability, wherever you do have duplicate values of data, there you can apply this distinct filtering mechanisms. Such as if we take a example, certain example, that if X is a user who logs into a particular web browser, and through this web browser he is logging into a website. Now, from a particular device will have a MAC ID. So, all these things will be unique for a particular user, but every time when he gets logged in through the same things such as same user, same device, same browser and same website, then duplicate nature of data gets created. Duplicate nature of data. All this data along with that what he has browsed on that particular website. So this type of duplicateness is not required when it gets stored into weblogs. Only one with the necessary web browsing is required. So in certain scenarios you can apply distinct filtering, where the structure comes like this, where mapper is going to be applied with two parameters, key and record, where it emits only the record, this one, with the null values. Values can be anything, that is what he is browsing after that, and this is being passed to the reducer phase. In the reducer phase what it is emitting? Only the key, not the records. So this is how we can just reduce the data from the entire data set. Coming to the mapper function, this is an example for your distinct filtering. In the mapper function, from a particular set of users.xml file, we are going to retrieve the user ID and it will be stored in a user ID, and this user ID is passed into the set function where it is setting it to the user ID, and it will be returned to the output context with a null writable as a value, same as the structure. Here record is emitted but with a null attribute. Sorry. In the reducer phase, nothing much to be done in the reducer phase, as it is already retrieving the distinct values. So it will be printing the key with the null writable into the output file. This is all about all the filtering patterns. Thank you.